The whole point of the next three examples is to really solidify the idea of this transformation formula of y equals to a square root of b x minus h plus k. I really want to burn that into your brain to make sure that it works. So let's look at the first example. It says, what is the vertical stretch when it's applied to this graph? And I know what you're saying. This graph doesn't have a vertical stretch. Well, that's the point. We're going to apply a vertical stretch. We just don't know what it is yet. And how are you going to do this? Well, the transformed graph is going to pass through a new point called 418. So you're going to put some kind of vertical stretch here, and that new vertical stretch is going to force the graph to go through that point. Ah, I kind of see it. So we don't know what that vertical stretch is. So you know what? I'm just going to put an A there. You know the vertical stretch is A. That's what's determined here. So I'm going to take this graph, I'm going to put an A up front, and I'm going to determine what that A is. So here's the original, 2x plus 1. I want to find what is that vertical stretch. Oh, I'm beginning to understand now. So how do we do this? Real simple. That's x, that's y. Plug it in, find A. It's that simple. Oh, okay. So y being 18, there's that a that we're trying to figure out. Square root, there's a 2. The x, of course, is 4 plus 1. Well, 2 times 4 is easy. That's 8 plus 1 makes it 9. So this is the square root of 9 times a equals to 18. Square root of 9, of course, is 3. So I got 3a equals to 18. Divide by 3, both sides. A works out to be 6. So this new graph, here's the old one. The new one is going to be y equals to 6 square root of 2x plus 1. Now, I know what you're saying. Is there any way that you can actually prove this? Well, actually, yes. I'm going to pop this right into my calculator. Look, I've already got the graph in there, already got the number in there, and I'm just going to go out and I'm going to graph it. Okay, hit graph, boom. Well, that doesn't tell you a whole heck of a lot. But what does tell you something is if you go second and then hit the table, and I already got a red arrow right beside it. Bada boom. Look at that. There's the 418 that was given in the question right here. So that proves by putting that 6 up front here, this graph does in fact go through 418. Ah, cool, right? Okay, let's take a look at 2 more questions that are also very cool. Look at this next one. Example 4. It says, as a result of the transformation of this, so as a result of this, okay, into this graph here. So there's the original, which we all know. Now I'm giving you this graph, which is your newly transformed graph. You're going to take a point, bada which was the original, is now transformed to a new set of coordinates. Okay, find out what those new coordinates are. Oh, gee, I think I can do that. Real simple. I'm going to take this original graph, which is 2y equals to the square root of x plus 1. But the problem is, I've never had a 2 up front like that. Well, yeah, so get rid of it. Divide both sides by 2. Look at this. Gone, leaving you y equals to 1/2 square root of x plus 1. Now, interpret what you have there. Well, there's your a value. Oh, okay, so your a value is 1/2. There is an h value. Your h value is -1. Think about how this affects the graph. This a value is a vertical stretch factor of 1/2. So this is going to, of course, result in something happening to the y's. This guy is a horizontal move left of 1. That, of course, is going to be with your x's. Okay, so let's just apply this to our original point. Our original point is right here. Right there, 64.8. Okay, so a vertical stretch of 1/2 affects the y, so multiply that value of 8 by 1/2. Oh, I end up getting a 4. There's my new point. Okay, and your h is a horizontal move left of 1. So there's my x values. I'm going to move left 1. So I get a point now of 63,4. There's my new point. Done. Well, that wasn't so bad. That was actually kind of neat. Okay, let's look at the last graph, or the last question, which is this one. Now, let me get out of this for a second here. There we go, clean it up. Look at this one. This is the graph of f of x. So the original f of x, of course, is that radical function that we're so used to. But now we're going to translate it. But look at this, horizontally and vertically. There's no stretch factor here. There's no vertical stretch. There's no horizontal stretch. There's no reflection. There's no nothing. So let's think about this. Your a value then is 1, and so is your b value. Okay, so no stretches, no reflections. A and B are both 1. Perfect. So we're looking strictly for horizontal and strictly for vertical. All right, let's read the rest of this. Oh, check this out. Isn't domain part of the endpoint? Isn't domain part of the thing that says you start here? That's what this is telling you. Okay, so why don't we just graph that? Let's graph it. Minus 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's minus 10 way out here. Isn't this 2? Isn't the range determined by looking at the graph? And sure, it says it's a value of 2. Okay, so we have minus 10, 1, 2. You are starting right here. Now, interpret what domain means. These are all the values that are bigger than minus 10. So if you're bigger than minus 10, you know that this graph is going to go that way. And look at this. All the values that are bigger than 2, that means the graph is going to go that way. So you know that being that this is a radical graph, its shape should look like this. Well, guess what? There's your starting point, or what we call end point. You know that the graph has to go this way and up. So this is basically going to look like that. Oh, cool. So what just happened? What just happened is this. You have to describe the horizontal and vertical translation in words and then throw it in this notation here. Oh, okay. So the cool thing is, if you look at this notation, like I said before, the A is 1, the B is 1. There's no A, there's no B. They're both 1. So that's not a part of the formula anymore. But how much did you translate this? Oh, okay. I went left 10. I went up 2. Okay, there's my words. Done. But now let's put it into this formula. Y equals 2. The square root. Left 10 means that this is, in fact, a negative 10 for an h value. And if you pop it in here, look at that. You're going to get that negative thing. So this is going to be x plus 10. And your k value is up to, that's going to be on the outside, plus 2. That's what that new formula looks like. Huh, interesting. So I hope this really helps solidify this idea of that transformation or formula.